Hello everybody, Mike from StarStructure Telescopes, and this will be another StarStructure short video. In this one we're going to be showing how we do the alignment of our secondary holder to our focuser. If you attempt to do this yourself, it's important to understand that we do manufacture all these components in-house. This gives us a reasonable understanding of the accuracy that we have, which makes this system, this type of system possible. Want to point out a few things like this is the underside of the spider where the secondary adjustment plate will go to. This here is a 1/16 of an inch self-adhesive Teflon liner that we put in here. This will sit in between the adjustment plate and the spider, and this is what will create our rotational. Most other manufacturers will have this hole tapped to go down the threaded rod with some kind of nut. Loosening, moving that nut up and down on the threaded rod is how they adjust to and from the primary of the secondary. In this case, we have eliminated that adjustment completely. Another thing that we've done, you can see here, this is the base of our secondary holder. You can see these holes countersunk into it that correspond with the adjustment holes on the base plate. What this does is it locks these two together so they can't rotate, which is why we don't have to tap this hole. This will now be true centered for our bolt to go in. This was already pre-done to keep the video as short as possible, but the other thing that I want to show is I want to show this setup, which is a sight tube in this holder that we made, and then over there you can see I have a square with a line on it. What we've done here is we have centered this, we've pre-done this. We had the entire secondary installed. We've installed the spider, we've centered it, we've torqued it up to its full tension. We had the holder installed already. We're going to show this quick, but I just want to go through everything. And then we have measured from the table to the center of the secondary holder with the sight tube. And then what I did was to ensure that the sight tube was shooting a straight line parallel to our welding table. We made a mark on our square, and then we've looked through our hole to the other side to make sure we're shooting a straight line and got everything square. I now reassembled everything to show you how that was done. So basically, once we know we have our sight tube shooting parallel to the table, we insert the upper assembly with the secondary in place, and then we sight it in the sight tube, which now will basically give us an understanding of our measurement from the flat of the table to the center of the sight tube. I went ahead and reinserted the focuser board upside down. You can see it's not lined up, but by doing this, once we know our height off the table, then I can make a mark on the focuser board, which you can see here, and then drill our focuser hole really close to where the secondary center is. So once that part of the process is done, now what we have is we have our focuser hole drilled as close as possible. Don't forget, this is done by eye, to the center of the secondary holder. What's important to understand is the final adjustment is going to be done to the glass, not to the holder. So what we're hoping to achieve here is just to get it as accurate as possible within our adjustment amount. The adjustment is done quite different, and the space between the adjustment plate and the base plate of the secondary holder is all we have, which equates to about 1/10 of an inch in each direction. So my goal here is just to get that hole so we have adjustment for plus minus 1/10 of an inch. The final step in the process will be to actually install the feather touch focuser, put the sight tube in it, and then line up the focuser board focuser assembly to the secondary holder. This will get us as absolutely close as possible right from the get-go. Once this is done, we can go and once we get this lined up, we'll clamp our focuser board in place, and then we'll weld the focuser board to the front end. Of course, we'll remove the feather touch when we do that. Then we'll reinstall the feather touch and double check it. At that point, I can do any adjustments to the secondary to get it, again, lined up close. We need to wait till the glass is in before we're going to get, lined up precision. But this will just ensure that when we assemble the telescope, 9 out of 10 times, all I have to do is a little tweak. Here I've replaced 2 of the set screws with the adjustment screws. You can notice I only did 2 of them. These 2 will remain as the flush mounted set screws because they are not supposed to be touched, assuming that everything is accurate. And this system does get everything accurate. So to do any final adjustment of the secondary holder to closer or further away from the primary, the system will be as follows. To bring the secondary down, okay, we'll have to loosen this nut, which will allow the holder to drop, and then we will adjust these in until the plate is back up against the spider. This opens the gap up there and brings the holder down. The reverse would be to back these off. And when we do this, we always want to turn them equal amounts. So if we do 1 turn, we do 1 turn on all of them, half a turn on all of them, whatever it may be. So this way you don't lose your place. So then again, to bring the holder further up or closer to the spider, we will loosen all of these equal amount, and then we tighten this nut, which will close that gap, bringing the holder closer to the plate and up higher. The adjustments are all done here, so it's nothing you have to worry about when purchasing one of my scopes, but that's the difference as compared to the way it's normally done, where we loosen a nut and then there's some nut either below this plate, in most cases above this plate, that you have to loosen with that nut to raise and lower the secondary holder. There's a lot of benefits to this, mainly keeping that holder as close to the spider as possible, especially in these really big secondaries. This is a 30-inch f3, so this is a 7-inch secondary. So, keeping that weight as close to the center of the spider is definitely a benefit. But anyway, I hope this helps understand how we are doing things here. This is obviously a very long process because it requires that we put it together and take it apart and then put it together again to ensure everything is straight. But in my opinion, it gets that alignment near perfect right from the get-go, and that's what we're trying to achieve here. All right, hope that helps. See you next time.